Hey Kathleen, quick question for you. What is vector search?
Quick question? Well, let me explain. Traditional search is text-based, using a data structure known as the sparse vector field type. We take a bunch of text, we parse it into keywords, and we store these keywords in an inverted index with metrics such as term and document frequency. With vector search, we take that same text, but we run it through a model and we translate it into a certain number of dimensions that are represented as floating point numbers. We create vectors through a process that we call inference. What is the difference between vector search and semantic search? Semantic search looks for the meaning and the underlying intent behind your query, while vector search looks for similarity between different mathematical vectors. Under the hood, most semantic search is powered by vector search. What is the difference between sparse and dense embeddings? Let's start with what they have in common. We take some content, we perform inference using a model, and we create and store those vectors in a vector database. Now, sparse embeddings have a ton of dimensions. Think every word in the English language. But for most documents, the vast majority of those values will be 0. It would be incredibly inefficient to store every single dimension with all of these 0 values. So instead, we store only the non-zero values, making it sparse. Text expansion is a great use case for these sparse vectors. And it looks very similar to how we search sparse vectors for text search under the hood. We take a bunch of these tokens and they come with weights from the sparse vector model, and we OR them together using those weights. Dense vectors have far fewer 0 values, so they can be stored much more densely. We translate those vectors into dimensions and store them in numeric floating point arrays. And then for the dense vectors, we use similarity metrics to search and return results. Well, that was a dense answer. We'll be back soon with more quick questions on all things search. And please check out all of our additional Elastic resources for much deeper answers, research, sample code, tutorials, blogs, and a lot more.